Okay, so the first thing I'm going to do here is actually describe to you what CoinJoin is. It was proposed by Greg Maxwell on the Bitcoin Talk forum, and it's basically a way for multiple participants to come together, create a transaction, and then actually, whenever they're creating this transaction, allowing a little bit of anonymity to come into it. And it does that by whenever there's kind of like, so again, multiple participants, there will be multiple inputs coming into it, and then multiple outputs, and each one of those participants has an output that's the same value. And the interesting thing about how these enter into the blockchain is you actually can't tell which one of the inputs went to that specific output that's the same value. So that actually allows you to have a great deal of privacy without kind of like any of these crazy mixing services or anything like that. Okay, so why do we need CoinJoin? Why is something like this important? So the first thing it does is it enhances privacy. Some of you may have heard of just kind of like all the different blockchain analysis and things like that you can do. Of course, you should be aware that everything you do with Bitcoin, it goes into a public ledger. Everyone can look at that and see exactly what each one of those transactions are. But the reality is, all of a sudden, whenever you make a transaction and that transaction goes to someone who then has identifiable information on you, such as your name, your email address, they can actually look in the public ledger and figure out kind of like where those coins came from and look back even further and kind of figure out a good graph of some of the things that you've been doing with your money. And of course, with kind of like being able to share these transactions, it helps reduce the ability to do that. Another thing is that it keeps Bitcoin fungible. Fungibility is a property of money that basically, like any kind of money should have this, and that's basically like Paige. If you have a dollar bill and I've got a dollar bill, and we decide to swap dollar bills, we both still got a dollar bill. Like both of us can spend that dollar without any problem. But there's actually projects going on where people right now are trying to make it where you can't do that with Bitcoin. They're actually creating, for instance, blacklists of addresses where if you're on this blacklist, and for instance, if one of those, some of those coins were sent to me and it was on that blacklist, I wouldn't be able to spend my coins for something I wanted. So there's, again, that's a very kind of bad property to have with your money system, but people are trying to build that into Bitcoin. And so another thing that it does is you're allowed to do trustless third-party mixing. So there's certainly quite a few different mixing services out there right now, but what they generally require is you send your Bitcoins to a specific address of someone else, you trust them then to return them to a different address. So during that period while they're mixing the Bitcoins, you actually don't own your Bitcoins. Someone else does, and you just you hope that they come back to you. And you don't know that they will. I mean, certainly there's reputation, but as we've seen, anything with Bitcoin, reputation can totally go out the window. Of course, Mt. Gox was a good example of something that was very trustworthy for a while, but certainly a lot of people lost a lot of coins with it too. So the example I'm going to give of a transaction is, let's say I want to donate 100 Bitcoins to WikiLeaks. So I've got a Bitcoin wallet, and you can see it here. It's got a specific address where I have the private key, so these are my Bitcoins. No one else has this. And there's 500 Bitcoins in my wallet. So whenever you create this transaction, basically how a transaction looks, it's got inputs and outputs. The input will, of course, be my address, my wallet. The output will be WikiLeaks' address, which will go to their wallet. And then another address that I own, which is the change address. So if you look kind of on the left-hand side, there's 500 Bitcoins. On the right-hand side, there's 500 Bitcoins. Basically, we just changed ownership of some of those Bitcoins. And you can see Julian Assange there. He's super stoked that he got 100 Bitcoins from me. So he's hanging out on his nice Ferrari with his shirt off. So that's definitely a real picture. Okay, so let's now continue with another transaction. So we'll start with now I've only got 400 Bitcoins in my wallet after sending money to WikiLeaks. Okay, so we're pretending we're in the future now. So we can actually pay taxes to the US government. This is a crazy world we're living in. The government's decided that Bitcoin is this awesome thing. It's now US legal tender because the US government loves it. So of course, knowing the government, they take half of my Bitcoin. So we're going to have to send them 200 Bitcoin. And the same thing as we did before. So we'll send them 200, and then I'll get 200 Bitcoin back to myself to an address that I control. So the interesting thing, of course, is that the US government knows a lot of information about me. They know, of course, my social security number. They know my name, my address. And what they can do with this information is they can start to look back in this public ledger, the blockchain, and they can actually see that, wow, it's a really good likelihood that this person donated 100 Bitcoins to WikiLeaks. And as we know, the US government, they don't like these things. So not surprising, they would want to put me in jail. Okay, so now we'll look at kind of like the same transaction we had before, but this time we'll do it with a CoinJoin transaction. And so again, you can see this is the initial where we're trying to donate 100 Bitcoins to WikiLeaks. And this time we'll go ahead and, so again, the whole point of CoinJoin was that you had people joining in, creating your transaction. You know, someone else will join in the transaction with us. So we don't actually know who this person is. This person could be anyone. It actually doesn't matter who this is. We can connect to them over the internet. We can connect them to this person over IRC. The important thing is that they actually have 100 Bitcoin too, because that's the thing we kind of want to make anonymous, where not everyone can tell what it is. And so they'll add their outputs into it. And again, they'll have two outputs. One of those outputs, again, will be that 100 Bitcoins. And then they'll have an additional change address, the same thing. So again, you'll see on the left-hand side, the totals match up to the right-hand side. But again, the interesting thing is now in that transaction that was created with these two participants, both of them have an output of the same value. And so when this goes into the Bitcoin blockchain, you actually can't distinguish which one of us sent to those output addresses. There's no way to do that. Bitcoin doesn't provide a way to do that. And so this actually makes it all the kind of like taint analysis and all the tools where people are trying to figure out like, where did this money come from? This actually kind of does a pretty good job of stopping it dead cold and just makes it where you have to fan it out and do a lot more just complete guesswork. And of course, this would make both me and Julian Assange buddies, because now we both got our money and nobody's in jail. Okay, so now I'll talk a little bit about CoinMux again, which is kind of like an implementation of this protocol. And again, kind of, so it's open source, it's on GitHub, it's trustless. So basically what that means is the application does ask you, hey, give me your private key, but that private key never leaves your computer. It's only on your computer. It never gets sent over the internet. You never lose control of your coins. It's decentralized. I'm still working on that part. And it's also anonymous, also still working on that part. Right now, if you use it, it definitely will leak things like your IP address, which, you know, if you're trying to be truly anonymous, you don't want to give away your IP address either. Okay, so now I'll kind of give a little bit of an example of this in use. So let me get this set up. Hold on one sec. Okay, so this application is actually written in Ruby, or generally Ruby, but it's kind of using JRuby. So that means kind of like underneath it's got a lot of Java code in it. So we actually, if you see here, there's kind of a Java jar file. And basically that's kind of like a runnable application that you can run on multiple different platforms. So I'll just double click that. Takes a little while to load, probably needs a loading screen and all sorts of wonderful things like that. And so remember, this is a development release. It's, you know, not ready for everyone to just use it and do whatever they want with it yet. But that said, it comes up and you can see there's a simple little kind of like dialogue application, basically just telling you that you can mix your Bitcoins, which of course that's the goal of it. And just kind of to note for everyone, right now it defaults to the testnet, which this probably means something if you're a developer, may not to you otherwise, but basically, testnet is kind of like a parallel Bitcoin network that is only for development purposes. And so this is so I can play around with sending coins to myself and not have to worry about doing something where I actually lose anything. So that's what I'll be doing now. And you can actually change it to mainnet. I've only created 2 transactions the whole time I've ever had this application. So do that at your own risk. That said, they were fine, but but do anything like that at your own risk if you want to use it. So what we'll do is we'll go ahead and we'll just do create new mix. And so we'll go ahead and we'll create a mix, and instead of doing 1 Bitcoin, we can pick a different amount. We'll do half a Bitcoin. And again, these are testnet Bitcoins, so not quite real Bitcoins. And we'll do it with just 2 participants because we're going to bring up another application, and we'll have both of them kind of talk with each other and create a transaction for this. And so you can see the 3 things that it asks for here is the input private key. So again, that's our input. This is the thing that shows that we own that input address. And that was it. I don't know if you saw it. Don't try to steal that. That was so that was our input key. There's an output address. And so you'll notice these, again, they don't look like probably the regular Bitcoin addresses that you're used to that start with the number 1. Instead, this is a testing address, and they usually start with M or N. So they look a little bit different. So we'll have an output address and a change address. Whoops, probably that guy. And again, if you remember how I kind of showed the diagram up there, there was the input, the output, which we're going to have the same value that someone else will send. And then we've got a change address where we send all the kind of like whatever's left over to. And then we'll just click start mixing. And it goes ahead, it validates the input, make sure I kind of like didn't have a key that didn't have enough money or was actually a valid key. And then it just sits there and says waiting for inputs. And that's where it's exciting for us to probably open up another copy of the application. So here we have another copy, and again, this other copy, like right now, of course, they're both on the same computer, but pretend in your mind for a second that this is someone else completely on the internet. Like I have no contact with this person. I've never talked with them. I have no idea who this is. But what I see is that someone's already got a transaction that they're trying to wait to create. And you can see it's half a Bitcoin and 1 of 2 participants. And of course, that's the one that the other person created and is just waiting for someone else to join in with them. So we'll go ahead and we'll join in with them. Whoops, wrong thing. And hopefully if you're on OS X, you're using Alfred because it's a great application. You can type in private keys and things without really typing them in. And I accidentally typed the wrong one here. And then we'll click Start Mixing. And you'll hopefully see these 2 will start communicating with each other. So all of a sudden they're kind of like going through the process of kind of like communicating with each other and figuring out what this transaction is going to look like. And then publishing to the blockchain or to the Bitcoin network takes a second. And then it says completed. So what that's actually done is that's created a transaction where at no time did either of the 2 of these participants have a chance of losing their Bitcoins. I could have just quit the application or anything and nothing ever left control of that person's wallet. And so we'll click view transaction, which may or may not show up. It went to Google, which was not what I was expecting at all. I think this is correct. Yeah, that's our transaction. We just got there. So again, this hasn't been confirmed by the network yet, but as you can see here, if we look, we can scroll down and we can see kind of like the 2 inputs. One had 19 testnet Bitcoins, not real Bitcoins. One had 11. And then again, if you look at the interesting thing here, at the 4 outputs, 2 of them are half a Bitcoin. And there's, again, looking at the blockchain, there's no way anyone can actually tell which one of those came from which of those 2 inputs. So that's kind of the demonstration I wanted to give. Yeah, and if anyone's got any questions, oh my God, people do, go ahead. I think the first question was, what if the US government says that mixing Bitcoins is illegal? And I think that's kind of the whole point of actually having this be an application that you run on your computer. Like with it being an application, this is something that can be distributed absolutely, there's nothing to shut down. Again, someone could totally take the source code away and like take it off GitHub. Like the US government could absolutely do that. But once the source code's out there, there's nothing really you can do. Someone else can critique this. You can pass it around on floppy disks if you really wanted. Anytime you have something where you have private keys on your computer, there is the potential for it to be compromised. And I think the best answer to that is like an open source operating system where you actually you're able to see all the code that's available on that operating system. I think my plan kind of as this goes forward is to actually have it where there's actually one person who's kind of trying to mix their coins, and then other people potentially get paid to help mix their coins. So I think that'll actually have it where it'll get a little bit of incentive for people to help you mix your coins. And then again, provide where there's probably only one potentially fishy transaction. But I don't think this is only for WikiLeaks or something nefarious. Like absolutely, again, anytime you're sending your coins to somewhere where they have your identifiable information, like they know something about all of they can look back into the blockchain and see things about you. Like I've definitely, I've bought Bitcoins off exchanges, and pretty much right after I put them into a cold storage. And of course, like pretty much every one of these exchanges, they can probably tell which ones of those have gone into cold storage. And it's really easy to do those things if you have an identifiable piece of information combined with the blockchain. You can actually get a whole lot of information. And so that's part of the kind of like coming soon part. There's definitely there's some cryptographic things that I can do to help enhance and kind of like even internally when the computers are kind of like talking with each other over the peer-to-peer network, and kind of help like actually hide who's talking to who. And there's some cryptographic protocols you can do with that. Additionally, of course, there's other things like there's anonymity networks, which this can pass through. So again, it could go through Tor or something like Tor to also help add an additional layer of anonymity. And just to add one point to that even, so definitely there's also potential the government, of course, could be one of the participants. With anything with cryptography and security, you kind of have to do the best that you can. So there's no kind of and there never will be just like a golden solves every single situation, but you can improve your security. So I think the question is, could you add something into this application that would potentially maybe allow a third party, potentially a government, to kind of see what's going on with this? And definitely the goal is to do the opposite. And the goal is to actually make it where governments can't see it. Yeah, and that's something I think certainly Satoshi, whenever he kind of released the initial white paper, he knew that there are problems with kind of the privacy of the transactions. And it's difficult to solve to get them where they are actually where privacy is part of it. And not everyone, of course, wants that solved. Again, so talking before, there's people who are creating basically blacklists of addresses that somebody did something bad, and who's to say what's bad? Should it be the U.S. government? Should it be China's government? Should it be Google? I have no idea. It probably shouldn't be any of them, and definitely keeping within the spirit of Bitcoin, it shouldn't be any of them. So the question was, I guess, could you, instead of broadcasting the transaction, could you just store the transaction and potentially broadcast it later? Is that right? So I'll say the sit online and wait and twiddle your thumbs. That's definitely a problem with it right now, is kind of it has a low user base. And I think adding financial incentives into that will have it where people will actually, they'll be happy to sit and wait if you give them a small percentage of what's kind of going on with it. So then if I'm the person who's interested in mixing, there will already be people there who want to help me mix. And so I think it's just kind of setting the correct economic incentives. And then I think whoever's trying to do that mix can do it very quickly. So I think the question was about kind of confirmations of the transactions, and does it take 10 minutes to actually kind of enter into the blockchain? Yeah, and absolutely it does. And what you saw that got pulled up here immediately after had 0 confirmations. So basically, no one had kind of built the hash code that solves the Bitcoin puzzle to actually add this into the blockchain. That said, I'm sure if we probably refresh it again, it probably will be in the blockchain. So just because this application is showing things that have 0 confirmations, that doesn't mean it's not going to go into the blockchain. So, okay, Thank you, everyone. And again, if you want to check out the GitHub page or anything like that, CoinMux, you can find it. And definitely, you can also just search for CoinJoin on Google, and you can read about 20 different pages of people kind of talking about it. So thank you.